Hello students, so welcome back to the class. So we will continue with our some basic concepts of chemistry theory part 5. Disclaimer, the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the part of the content may have been generated using generative AI, which is experimental. In this class, our objective would be to calculate the mass percent of the component elements constituting a compound. Then we will see what is empirical formula and molecular formula, which is most important part of this lecture. Lastly, we will see how that we will how we will perform the stoichiometric calculations. Now, if I try to put the same thing in the form of the index, then first we will see percentage composition. Then we will see empirical formula for molecular formula, in-text questions, stoichiometry and stoichiometric calculations, limiting reagents. So what is percentage composition? So you should be very attentive now. Don't waste time in silly things, okay? So suppose we are talking about water. Then water has hydrogen and oxygen. We know it very well. So how do we calculate the percentage composition of each of this element? So it's very simple. We keep the mass of that element in the compound divided by the molar mass of the compound into 100. Now, let us try to understand this formula with the help of an example. We know that the molar mass of water is 18.02 gram. Then what will be the mass percentage of hydrogen? So the formula of water is H2O. Okay. The total molar mass is 18 gram. But what is the contribution of H2? So we will do it very simply. It will be 2 into 1.008 that we have done it here. So we are taking the contribution of hydrogen only. For that reason, we are doing this. In the downside, we keep the total mass. So if you consider 1 mole of water, okay, then in that 1 mole of water, we have 2.016 gram of hydrogen, okay, hydrogen, and 16.00 gram of oxygen. So we are just trying to calculate this contribution. Okay. So if you keep this formula accordingly, you will get 11.18%. Then we can do the same thing for the oxygen. It will be 16.00, which is the contribution of oxygen, divided by the molar mass of oxygen multiplied by 100. You will get it as 88.79%. So anyone has any issue till now? They can ask. Okay. Moving on further. We can do the same thing for the ethanol also. What is the molecular mass of ethanol? To know that, we must know the molecular formula. It is given as 2 into 12.01 for carbon, which is 2 in the count. Then 6 hydrogens are there, 5 here and 1 here. So 6 into 1.008 plus 16. It will give you 46.068 grams of as the molar mass of the ethanol. So students, for the bilingual case, you have to go and visit the website. Here we will continue our lecture in English language. Okay. So this will give you the molar mass of ethanol as 16.068. It's very easy to understand. So if you have any issue, you can ask. I have already explained this average mass thing in the previous class. Okay. Now we will move on how do we calculate the mass percentage of carbon. So for carbon, it is 24.02 because there are 2 carbons. So 2 into 12.01 divided by the molar mass into 100. It will give you 52.14%. So why are you asking about average mass? It is being already explained. Then the mass percentage of hydrogen. divided by the molar mass into 100. It will give you 13.13%. Then what is the count of oxygen? It is 1. Yes, the molar mass is equals to the molecular mass. As simple as that. So the molar mass of water is, the ethanol is 46.068. In the upon side, we have taken the contribution from oxygen. One oxygen will give you 16 gram. So this will give you 34.73. Anyone has an issue till now? Till this question? It will be available in 1 to 2 days. Don't worry. So we are working on it. In this calculation, anyone has an issue? They can ask. Okay, moving on further. So basically, percentage composition, you can think of it. So why are we not taking it as 1? Okay. So we are taking it as 1 only. But since there are 6 hydrogens in total, you have to multiply this thing by 6. So take it as a thing like you are calculating, you are trying to calculate your percentage. Okay. They are trying to calculate it is your percentage. Then what you will do? You will take your total marks, keep it in the denominator. Take your marks that you have obtained, keep it in the numerator, multiply by 100. But here if you see, then you can see it very clearly that the contribution of hydrogen is 6. There are 6 hydrogens in it. So you have to multiply the atomic weight of hydrogen with 6 divided by the molar mass of the ethanol multiplied by 100. So what we are taking is we are taking the contribution of carbon in 1 mole of ethanol. What is the percentage of it in 1 mole of ethanol? Is it clear? So if it is given in the question that you have to take 1.008, you will take 1.008, or else you will always take it as 1. Yes, you can take it. There's no problem in it. Okay. But if it is given in the question, then you have to take it. If it is not, you can take the approximate value always. So it's very easy to understand. This concept is very easy to understand. You are just taking the atomic weight of carbon. Since there are 2 carbon, you multiplied with the 2, divided by the total molar mass, multiplied by the 100. So for never take it as a decimal. So suppose it is 35.5, take it as 35 for chlorine. Don't take the values after decimal if you want to approximate. For S and P block elements, you must remember the atomic weight. Okay, for higher or the D block element, it is not necessary but for the lighter elements, I would say up to the sodium line, you must remember. Okay, so moving on further. Next thing is the empirical formula. What is empirical formula? It is the simplest whole number ratio of the various elements that is present. Okay. Whereas the molecular formula is the exact number of different type of atom. For example, if we are taking glucose, then its formula is C6H12O6. So this is your molecular formula. What it is? It is your molecular formula. But if I ask you what it is empirical formula, how you will know it? So we take the common thing. So 6 in common in all of this. So divide each of the coefficient by 6. Then what you will get? CH2O. So this will be your empirical formula. So it is the simplest ratio that you can take for a given coefficient. Clear? So this is the difference between molecular formula and the empirical formula. Till now, anyone has an issue? Okay. Moving on further. So suppose if you want to know the empirical formula, how you will know it? You can do it if you are aware about the mass percent of each of the element that is present in your given compound. So I will give you one more example. Suppose it is written as, suppose it is C2H6. Then this is your molecular formula. Okay, this is your molecular formula. What will be your empirical formula? EF. So the common factor that you can take in 2 and 6 will be 2. So divide this whole thing by 2. You will get it as CH3. Is it clear now? Yes, yes. So do all alkane and alkyne have the same molecular formula? No, it's not possible. So alkane has a molecular formula like this, an empirical formula which is this. If I take the corresponding alkyne, which is CH2, then its empirical formula will be CH2. You can't take a simpler ratio. So of course, empirical formula and molecular formula for both are not same. Now, coming back to our point, that if you are aware about the mass percentage, then you can easily calculate the empirical formula. Let's see how we can do it. And further, apart from the mass percentage, if you have the molar mass also, then you can know the molecular formula as well. So what should I repeat, Nandini? What should I repeat? So it is the simplest whole ratio number. Okay, Nandini. So suppose we have glucose as C6H12O6. Okay, we have C6H12O6. This is called as the molecular formula, which tells us that what is the actual count of the number of atoms that are present in a molecule. So if you take a molecule of glucose, you will have 6 carbons, 12 hydrogens, and 6 oxygens. But whereas empirical formula, if I write it as EF, it is the ratio of their count. So if you divide this, if you take the ratio 6 to 12 to 6, you can reduce it further to 1:2:1. Now keep them as it is. So you will get CH2O. So C1H2O1. So what is unknown? What is not known? So this formula is go for yes. So if you are not aware about the molecular formula, you can't get the empirical formula. But if you have this mass percentage, you can get it. And if you have the molar mass and mass percentage both, then you can have the molecular formula as well. So you should be attentive, right? Okay. So when I am telling it, you should be attentive because we are lacking time. So what I am trying to say is that alkane. So somebody asked that does alkane and alkene have the same empirical formula? So say I said no. Okay. So you can just try to calculate it by yourself that how they have the different molecular and they have the different empirical formula. So let us move further now. So here we have a question, and here it is given the mass percentage of hydrogen and carbon and chlorine. And then with the help of this, you have to calculate the empirical formula. Further, you are also given the molar mass, with which you can calculate your molecular formula as well. So you should be now attentive because this part is very, very important and it is asked in your CBSE exams also multiple times. And it is a bit lengthy but easy process to know. So let us try to understand this. Okay. So how we will calculate this thing? First, we will convert this mass percent into gram. How will convert it? It's very simple. Whenever you calculate the percentage, what you get? Okay, you get the amount of each of this element that will be present in 100 gram of the compound. Okay, again I am repeating it. Suppose if 200, out of 200 you got 100 marks. That means you got 50%. Now this 50% is saying that suppose your exam was of 100, then you would have gotten 50. So this thing is implying this. Okay, so you are converting your marks scale into 100 from 200. Similarly, when we calculate the percentage, we convert our thing into 100. It's very simple to understand that suppose you are taking the 100 gram of the compound, then the percentage will equal to the mass. That means in 100 gram of the compound, you will have 4 grams of hydrogen, 24.27 grams of carbon, and 71.6 grams of chlorine. Okay. So in this way, we can convert the mass percent to grams. Next, if we are knowing the mass, we can calculate the number of moles also. How will calculate it? We will simply divide the given mass by the molar mass. Yes, yes, it's very true, right? So if you are calculating the percentage, that means you are trying to calculate it out of 100. Okay. So you will take 100 gram. Okay. Then if you calculate the moles of hydrogen, it will be 4.07 by molar mass, which is 4.04. Then if we take the moles of carbon, it will be mass of given mass by molar mass, which is 2.021. And the moles of chlorine will be 71.65 by the molar mass, which is 35.453 grams. It is 2.021. So what is being added? Sorry, what two things you are trying to add? Okay. Okay, Nisagra. So what are you trying to add, Shaurya? So we'll move further. Okay. So again, I am repeating it. Suppose we are given the mass percent. Okay. So just remove the percentage sign and put grams. Just try to follow the algorithm. Remove the percentage sign and keep it as grams. Now this is your mass, which is now your given mass. So we have converted this percentage into mass by taking 100 gram of sample. If you have the mass, you can calculate the moles by using the formula given mass by molar mass. Very simple. I'm just changing the percentage to gram and getting the number of moles. Sir, if we will take 100 gram, will answer change or not? So we are taking 100 because we have the percentage, right? So percentage is for 100. Okay, percentage is for out of 100. Percentage means only that we are trying to calculate the same thing out of 100. Now moving on further, we are now aware about the number of moles. So what are the number of moles that we got? We got 2.021 and 2 else moles. But out of these 3 moles, the smallest moles is 2.021. Okay, so we got 3 type of moles. First for hydrogen, then for chlorine, and then for carbon. But the smallest number of moles is for the case of hydrogen, which is 2.021. Therefore, we will divide each of the previous moles that we have obtained by 2.021. Again, I am repeating it. Convert your percentage thing into gram. Then get your number of moles. Out of all the elements, the one which has the lowest moles, just divide that mole value with each of the remaining moles. Okay, you will get the ratio of 2:1:1 in case of this compound. Now, we can write the empirical formula if we have gotten this smallest ratio. It will be CH to Cl. Is it clear now? Now we have to know the molecular formula. How we'll do it? For that, we will calculate the empirical formula mass. So, now our next target is to get the molecular formula. So, it's very simple. You have to just know the empirical formula mass. So, the empirical formula that we got was CH to Cl. Just use this to calculate the empirical formula mass. 1 carbon means 12.01, 2 hydrogen means 2 into 1.008 plus 35.453 because there is 1 chlorine. You can write it in any way, right? You don't have to worry about it. you will get this empirical formula mass as 49.48 grams. Now we are given with the value of 98.96 as the molar mass. Divide 98.96 with the empirical formula mass that you got and get the value of N. Now multiply each of this with 2. It's very easy. So it was our initial empirical formula CH2Cl. Just multiply this 2 with each of this count. So carbon has 1 as the coefficient. So 1 multiplied by 2 will give you 2. Hydrogen has 2 as the coefficient. So 2 multiplied by 2 will give you 4. Chlorine again has 1 as the coefficient. So 2 multiplied by 1 will give you 2. So your final molecular formula is C2H4Cl2. Is it clear? So this is the way you can calculate the molecular formula. Now those of you who have an issue, just go through the calculation once again. It's very easy to understand. You can go to the YouTube and visit or you can see the video once again to get a more clear picture of how you do it. So it's a bit lengthy but an easy process to do. If you try it one by one, each of this, then it will be very clear. Now moving on to the stoichiometry and stoichiometric calculation. So stoichiometry is basically used for the calculation of masses of reactants and the products that are involved in chemical reaction. Yes, it's very important to find the empirical formula because you are multiplying the empirical formula with the n factor to get your final molecular formula. It's very important. Suppose, what are the things that you can get with the help of a given stoichiometric equation? So let us try to understand this because there is a lot of confusion regarding this concept. Suppose I say that we are having this equation which is CH4 2O2 CO2 2H2O, where all of the existing species are in gaseous state. What can be derived from this equation? First thing that can be derived is that the methane is reacting with dioxygen, that is, it is combusting to give us reactant as carbon dioxide and water, which are the products. Now, this G in the brackets represent their state. And if we have S and L, then they would represent the gas and solids. Now, we can say it from this equation very well that O2 has a coefficient of 2 and H2 has a coefficient of 2. Whereas the methane and the carbon dioxide has a coefficient of 1. Now, what are they representing? First is the molecule. So, we can say that this coefficient are representing the molecule. If they are doing so, then we can say it very clearly that 1 mole of methane is reacting with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. We can also say that 1 molecule of methane is reacting with 2 molecules of oxygen, giving us 1 molecule of carbon dioxide and 2 molecules of water. So these both things are clear from the same equation. Next thing we can say that since all of these are gases and all of this is occurring at STP, remember to yesterday's class that at STP, 1 mole of every gas has 22.4 liter of it. Therefore, we can say that since it is 1 mole, then we can say 22.7 liter of methane will react with 45.4 because there are 2 moles. So we will multiply this 22.7 by 2 to get 45.4 to give us 22.7 liters of carbon dioxide and 45.4 liters of H2O. Why I am saying this? Because the particles or the species involved in it are gases, and we have seen that what is the volume of gas that is present in 1 mole. From that you can get it for the 2 moles also. Next thing, if we know the moles, then we know the mass also. So 1 mole of methane will have a mass of 16 gram. 2 moles of oxygen will have a mass of 2 into 32 gram, which is 64 gram. 1 mole of CO2 will have a 44 gram mass, and 2 moles of water will have a 36 gram mass of water. Hence, we can say that 16 gram of methane reacts with 64 grams of oxygen to give 44 grams of carbon dioxide and 36 grams of water. Yes, 16 is the molar mass, okay, because we are taking the gram. Yes, Nisagr, what is your point? So Na was your Avogadro constant. Now we can say from this relation very well that with one equation we can get mass, we can get moles, and we can get number of molecules as well. If all the species are gas, then we can get the volume as well. So its value was 6.022 into 10 to the power 23. Now moving on to the next concept, which is limiting reagent. So in our real life, we carry out the reaction in which we have different amount of reactants and products. So STP has a full form of standard temperature and pressure, where the temperature has a value of 0 degrees Celsius and pressure has a value of 1 atm. Now, in such a situation where you don't have a fixed value of reactant and product, the amount is decided by the balanced chemical equation. But if suppose we can see in the previous equation that 2 moles of something is reacting with 1 mole of the other to give the product, but suppose one of the reactant is present in a small amount, what will happen in that case? There will be no further reaction, and that species which is present in a small amount or it is not present in the required amount will be named as the limiting reagent. For example, if we consider the formation of water, it is H2 plus O2 giving us H2O. So if you balance this equation, you will have half O2. Now what is the molar mass of H2? It is 1. Okay. What is the molar mass of O2? It is 16. But since we have half moles of it, so half mole means 32 by 16. 32 by 2, which will give you 16. Means in half mole of O2, we will have 16 gram. 1 mole of H2O, we will have 18 gram. So we can say that 1 gram of hydrogen will react with 16 gram of oxygen to give 18 gram of water. So we have just calculated the number of moles, and from there we have calculated the molar mass. So moles is already given. But suppose in our actual case, we have 1 gram of hydrogen. Okay. But we have what? We have 32 grams of oxygen and the product is not formed. But after the reaction, what will happen? If the reaction is completed, this 1 gram will react with 16 gram, but there will be a resultant O2 that will be left in your mixture. So after the reaction, the 0 gram of H2 will be left, whereas the 16 gram of this will be consumed, resulting in 16 gram left in the reaction mixture, and the formation of 18 gram will take place. Okay, got it? So in this way, what you can say that hydrogen is being consumed or it was present in a lesser amount. So here your hydrogen is the limiting reagent. Okay, again I am repeating it. So suppose in the reaction you have the 1 gram of hydrogen and 32 gram of oxygen and the product is not formed. If the reaction goes to completion, then 1 gram will react with the 16 gram of O2. As a result, the hydrogen will be consumed completely. So 0 grams will be left. After consumption of 16 gram of this oxygen from 32 gram, you will be left with 16 gram of oxygen and the formation of water will be 18 gram. So we can easily say that hydrogen is the limiting reagent as it was present in the lesser amount, whereas your O2 was present in a greater amount, which is already left. So H2 is the limiting reagent. Is it clear? So you must know the balanced equation. Yes, Nisarg, what is the doubt? Yes, you can do the same thing with the 2H2O2. You will get the same result. Okay. Just try it by yourself. You will get the same result. So we have to cover more questions, Nisarg. So you can just try it by yourself. Okay. So Riya, I was telling that if you take this equation, that then according to this equation, we can see it very clearly that 1 mole of H2 is reacting with half moles of O2 to give 1 mole of water. Okay. Now in 1 mole of H2, now one problem is here. We will write here 2. Okay. So sorry for this confusion. Why I am writing it 2? Because there are 2 hydrogen atom and 1 hydrogen atom has 1 hydrogen atom has 1 as the mass. So 2 will have 2 as a mass. Okay. So this will be 2 here. Okay. Now, next, if 1 mole of hydrogen is reacting with half mole of O2, we can say that 2 grams of hydrogen is reacting with 16 gram of oxygen, because O2 will have a molar mass of 32, but since half mole is reacting, so 2 by 32 will give you 16. Now, if this will react completely, then it will give you 18 gram of oxygen of water, because as 1 mole of water is formed according to this equation. Now, suppose we are taking a case where we have, of course, 2 gram of hydrogen, but we have 32 grams of oxygen. Means more amount is present than the required amount. As a result of this, the 16 gram of O2 will be consumed, but the remaining will be left in the solution. Therefore, H2 was present in a lesser amount. We can say it. So H2 is the limiting reagent. Is it clear? Okay. Now moving on to some questions. Okay. So just wait for a while. I will get back with this question. So now we will do the NCERT exercise of some basic concepts of chemistry. So I have taken some important questions here. Let's start. So disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So here is your first question. So if you are not able to get some points, don't worry. We will discuss this thing again in the questions as well. So we will have a doubt session in the coming classes. So once I will get all this theory part, we will have this doubt session. Okay. Our first question is, we have to calculate the amount of carbon dioxide that could be produced when we burn 1 mole of carbon. When we burn 1 mole of carbon in 16 gram of dioxygen, and 2 moles of carbon are burnt in 16 gram of dioxygen. So be attentive now. If you are not able to understand the stoichiometric and limiting reagent thing, I will make you understand in this question definitely. Okay. So let's start. So first of all, our first question is saying that we have to say that what is the amount of carbon dioxide that will be formed if we are taking 1 mole of carbon. So let's see, Devangi, what is the answer? If it is 44 gram or not. How we'll do it? So for that, we will use the stoichiometric equation for the combustion of carbon. If you are burning 1 mole of carbon in air, then we can say that 1 mole of carbon will react with 1 mole of oxygen to give carbon dioxide. So this is your balanced chemical equation for the combustion of carbon. So what is the meaning of this stoichio or stoichio? Are you asking the spelling of it? For spellings and all, you can go and check it with this NCERT. It is well given here. So coming back to this question, again students, just concentrate here. So what are we trying to do? We are trying to calculate the amount of carbon dioxide that will be produced if we burn 1 mole of carbon in air. So if we are burning in air, then the amount of oxygen is unlimited, right? With respect to the reactant, because reactant is a very small amount. Is it? Because in air we have lots of oxygen that is present. So you don't have to worry about the oxygen. Next, we can say from this equation very well that 1 mole of carbon is reacting with 1 mole of dioxygen to give 1 mole of carbon dioxide. Hence, if we take 1 mole of carbon and react it with 1 mole of dioxygen, then we will get 1 mole of carbon dioxide. Then what is the mass of 1 mole of carbon dioxide? Just calculate the molar mass, which is 44 gram. As simple as that. Is it clear? Is this first part clear to you of this question? So yes, 44 gram is the answer. Anyone has an issue? It's very simple, right? So we are given 1 mole. So if 1 mole of carbon is burning, it is clear from the equation very well that we will get 1 mole of carbon dioxide. And in 1 mole of carbon dioxide, we have 44 grams. It's very easy. Carbon has a 12 as the atomic weight, oxygen has 16. Since 2 oxygens are there, so multiply this thing by 2, you will get it as 44 gram. Again, I am repeating it. So we are being asked that if we are burning 1 mole of carbon, what amount of carbon dioxide we will get. So according to this equation, you must know this equation. So if you burn carbon, you will get carbon dioxide. So 1 mole of carbon, according to this equation, will burn with 1 mole of oxygen to give 1 mole of carbon dioxide. Okay. And in 1 mole of carbon dioxide, we have 44 gram. This can be calculated with the help of molar mass thing. Okay. Clear? Moving on further. The second question is saying that now we don't have an excess of air. We have only 16 gram of dioxygen. Remember students, we have only 16 gram of dioxygen. Now if we do this combustion of 1 mole of burning into 16 gram, then what is the number of moles in 16 gram? For dioxygen, we know that the formula is O2. Then the number of moles will be given mass, which is 16 gram, by molar mass of dioxygen, which is 32. It will give you 0.5 mole. It means we have only 0.5 moles of oxygen. Is it clear? But it is very clear from our equation that for burning 1 mole of carbon, we need 1 mole of dioxygen, whereas we have only 0.5 mole. It means your dioxygen is present in a lesser amount and hence it is the limiting reagent. Okay, so this is clear with this example. Again, I am repeating it. You have 16 gram of dioxygen, which means you have 0.5 moles of dioxygen. But according to the stoichiometric equation, for burning 1 mole of carbon, you must have 1 mole of dioxygen as well. But this dioxygen is present in a lesser amount, hence it is a limiting reagent. Now we can say that if we have this initial case of CO2, initially we have 1 mole of carbon and 0.5 mole of dioxygen. Product is not formed, it is 0. After the complete combustion of carbon, this whole carbon will be consumed, which will result in 0 mole of carbon. Okay? No, sorry. Which will result in 0.5 mole of carbon, because to burn the whole 1 mole, we need 1 mole of dioxygen, but we have only 0.5. So with this equation, we can say that if we have 0.5, then it will react with 0.5 mole of carbon only. Okay. So 0.5 will be left. So this is the left carbon. It is the left carbon after the combustion. Now, since this was present in a small amount, this will be consumed only, and the amount of carbon dioxide will be produced is 0.5 mole. Is it clear to everyone? Is it clear, this thing? Now, in 0.5 moles of dioxygen, we will have 22 grams, because we have the formula as number of moles is equals to given mass by molar mass. What is the doubt, Mona Lisa? So therefore, given mass can be calculated as number of moles multiplied by molar mass. Our molar mass was 44 and given mass is 0.5. तो हमें यहाँ पे क्या sorry. So we have to calculate here gram, okay, because we have to calculate the mass. So we will take the molar mass, of course. So what is the issue, Rajat? You can ask it, okay? You are very free to ask the question. The thing is only that you should be attentive while attending the class, okay? Then you can ask the question. Why 0.5 mole of carbon dioxide? Okay. I said it earlier that 1 mole of carbon will react with 1 mole of carbon dioxide to give 1 mole of oxygen to give 1 mole of carbon dioxide. Okay, according to this equation. But in the equation, it is written that we have only 0.5 oxygen. So in that case, it can only give 0.5 carbon dioxide. It is a direct result of conservation of mass. Okay. If you are following the conservation of mass, then it is very appropriate to say that if 0.5 of O2 or moles of O2 is reacting, then it will give you 0.5 moles of CO2. Now, moving on to the next and the last part is that we are burning 2 moles of carbon in 16 gram of dioxygen. So this is your question now. Again, we will calculate the number of moles in 16 gram. We have already calculated it. It is 0.5 mole. Here, what is your limiting reagent? So let's see according to the equation. So write the equation each and every time. CO2. Again, I am repeating it. So let me just write it here. Okay. So if 1 mole of carbon reacts with how much moles? 1 mole of oxygen. Then 0.5 moles of oxygen will react with how many carbon? So it's a direct unitary method. If 1 chocolate has a price of 1, then 2 chocolates will have a price of 2. Similar to that, if 1 mole of oxygen is reacting with dioxygen is reacting with 1 mole of carbon, then 0.5 moles of O2 will react with 0.5 moles of carbon. Okay? As simple as that. But in the question, we have 2 moles of carbon. Means excess carbon is present. We need 0.5 moles, but we have excess. So what is present in less amount? It is dioxygen. It's very clear from here. Okay? Limiting means simple, which is present in less amount. Again, if 0.5 mole of dioxygen will react, it will produce 0.5 mole of CO2. And in 0.5 mole, the mass will be 0.5 into 44. So if you want to calculate the mass, you will use the molar mass, right? Because you have to calculate the mass amount. So you will not take molecular mass. Sir, which one is LR? Is it? Yes, it is oxygen. It's very clear, right? It's oxygen. Because its amount is less. We need 2 moles of oxygen to burn this, 2 moles of dioxygen to burn this whole carbon. But we have only 0.5 moles. So it is the limiting reagent. Because we want to calculate the amount of carbon dioxide. We want to calculate the mass of carbon dioxide. But we have gotten the moles. To calculate the mass, we simply multiply it by the molar mass. If it is in larger amount, then it is in excess. The one which is getting wholly consumed or which is in a smaller amount is called as the limiting reagent. So we don't have a name for the excess one. Okay. Now moving on to our next question. Calculate the concentration of nitric acid in moles per liter if it has a density of 1.41 gram per ml and the mass percent of nitric acid is 69%. How we'll do it? Let's see. So we have to calculate the concentration in mole per liter, means we want to know the molarity. And it is given that the mass percent of nitric acid is 69%. Again, the same analogy, students. See here. If it is 69%, then by this we mean that the solution of 100 gram will contain 60 gram nitric acid. Same analogy that we use there. Okay. So Shaurya and Navpreet, don't continue this group thing here. It's not for fun because I am getting interrupted. I'm not able to see the useful messages. Okay. So coming back to the molar mass of nitric acid. So we know the mass of nitric acid which is present in 100 gram because again this percentage analogy is used here. Then what will be the molar mass? Why are we calculating the molar mass? Because we need the number of moles. And number of moles is simply given mass by molar mass. So the molar mass can be calculated as 63 gram per mole. It's very simple, a simple calculation. Number of moles will be 1.095 mole. Again, student, remember this analogy. 69% weight by weight means 69 gram of nitric acid is present in 100 gram of the nitric acid solution. Now we have converted this gram into moles, by which we can say that 1.095 mole will be present in 100 gram of nitric acid. Atomicity means number of atoms present in a given compound. So if you talk about the atomicity of hydrogen in water, it will be 2. Very simple to understand. So next thing is, we know the number of moles. Our next goal is to calculate the volume, because to calculate molarity, we need two things: number of moles of solute, and second thing is volume of the nitric acid solution. So if you are not able to understand this limiting reagent, we will get back with more questions to understand it. But in this case, we got the density in milliliter. Yes, very true. So to convert this thing into liter, we simply multiplied with 10 to the power minus 3. We got the liter also. Now coming back to the concentration which we were interested in, it will be mole by liter of the solution. Okay, volume of the solution in liter. It will give you 15.44 mole per liter as your concentration. So homoatomic molecules means all the atoms present in a molecules are same. So basically we are talking about elemental molecules. Yes, because it was written to calculate the concentration in terms of mole per liter. Okay. Our next question is, we have to calculate the molecular formula. So if you are not getting the idea of this molecular formula, we will do it again for the next question. Okay. So we have the mass percent of oxygen and iron both. And we have to calculate the molecular formula of oxide of iron. How will calculate it? So if the mass percentage is given for iron as 69.9% and for oxygen it is 30.1%, then the number of moles can be calculated. I said you that convert this percentage into gram. So this will be now gram. So given mass by molar mass, it will give you the number of mole as 1.25 for iron. Then the number of moles of oxygen will be 30.1 by 16. Okay, 30.1 by 16. 16 is the molar mass of the oxygen. So we have converted this percentage into gram again. Now what will be the ratio of this two? So you can do it. It's very easy. We have to take the simplest whole number ratio. This will give you approximately 1:1.5, which will be 2:3. Now, why we have done this? It is important. So, have you seen any formula in this form? F2.1.25, O 1.88? No, never. So, what do? We always take a whole number. So, for that, to convert this thing into whole number, I am dividing it by the smaller one. And I have told you earlier also, whenever you get one more number of moles, you divide the smaller one by each of this. Okay, I have told you already. So the smaller one out of these two is 1.25. So I have divided this both by 1.25. But again, the ratio that we are getting is 1:1.5. So 1.5 can be written as how? It can be written as 3 by 2. So to convert this fraction into whole number, we multiply it by 2. So we get 2:3. So the concentration formula is mole per liter. And why concentration formula can be anything, but in that question it was written, if you go back, then it was written that you have to calculate the concentration in mole per liter. So that therefore we have taken this. Now students will ask that we don't have the molar mass, but how we are able to calculate the molecular formula? Because the ratio that we got is 2:3. Okay, it is 2:3, and iron can form only two oxides. Okay, no, concentration is not equals to molarity. I'm again telling it. This was written in the question. You have to calculate the concentration in mole per liter. Therefore, we have taken it in molarity terms. Okay. So there are only two oxides of oxygen that are possible, which is FeO and Fe2O3. Therefore, we are taking this ratio as our final ratio without knowing the molar mass. Hence, our molecular formula, our empirical formula is Fe2O3. Now, if you calculate this thing, you will get it as empirical formula mass as 159.7. And the molar mass of Fe2O3, which will be given in your question, of course, it is not given here, don't worry. This will be always given in your question. So it is 159.69. You can approximate it as 1.5.67. Therefore, the N that the second step was being about, so it will be approximately 1. And hence, if you multiply 1 throughout this, you will get Fe2O3. Is it clear? So 3 steps. Again, I am repeating it. First, convert the percentage thing into mass. Then convert it into moles by dividing the following by the molar mass. Convert it into a simpler ratio. And finally, calculate the empirical formula mass and divide it by the molar mass to get the N factor. Multiply this thing with the N factor to get the final molecular formula. Is it clear? So what are you asking? But it is in general, what about other elements? So this was all for your today's class. I hope you got it. So if you don't understand it, you can just go back and look at our lectures in YouTube. Then it will be done. Okay. So in next class, we will meet again. So thank you for joining our session. So just wait for a while. Our maths faculty will be there in a minute. Yes, you will. Yes, you will get your recorded lecture as well on the website. Don't have to worry. In the next class, if you have any issue, you can ask it once again. So just wait for a while. The next faculty will come and join you. I'm, I'm trying my best to get you understand this chapter. Thank you.